Okay, so I have started recording. So thank you, Nawaraj sir, for your willingness to present on this. So you can start now. Thank you.
Hello, everyone. Good morning. Thank you, everybody, for giving me this opportunity to present. So I'm Nawaraj Dahal, and I'm a faculty at the University of Arkansas at Fort Smith. So today I'll present on the forward, central, and backward design in curriculum. What I have done, I have not outlined the topics for the talk. I'll just dive into the content. I just want to save time from that. Let me do, yeah. So when we talk about, let me minimize this topic here. Okay, so when we talk about the curriculum design, there are basically three parts to it. So the input part where we decide the content and put together a syllabus. The process part will be where we determine what we do in the class. So what methodology we use, what teaching activities we use, and how we teach the content that we already decided to teach. And the third part is the output part where we will do the assessments and see if our learning outcomes are met. So we decide what learning outcomes we want to have from the class, and then we decide how to assess them. Now, depending upon which part we first give emphasis to, so for example, do you emphasize input part, or we give priority to the process part, or to the output part, determines the forward, central, and the backward design of the class. So if I want to have the forward design of the process, so I should first start with the content, meaning I should decide what to teach. So I should put together a syllabus for that. So I will decide what content I would use in the syllabus. Then taking the output of that content, I'll decide what process to use. So what are the methodology that I want to use in the class? And now after that methodology, I'll decide what are the outcomes of my class. So what students really learned from that class. And I'll set up an assessment to assess either those learning outcomes are made or not. So that is really the forward design. So we start with the content and go to the process and finally to the outcomes. Now, this model is also referred to as the waterfall model by Tizer and Whitman 1990. It's basically because the output from the one stage serves as the input for the other. And you should decide the content first, the syllabus first, and then only your methodology and the outputs can be determined. It cannot be done the other way. And so how do we decide a content in the syllabus? It really depends on the person that is putting together the syllabus. So how much he knows about the topic, what he thinks are the important aspects of the topic. So for example, if he's going to put together the University Physics 1 class, now it really depends on what topics he thinks are important for the class. So all of those contents are developed around the field of knowledge of the person that is putting together it. And after he after he determines the contents and the syllabus, then the concepts or what knowledge and skills to impart to the students will be decided, and it will be decided after we have chosen the contents. So in this design for the curriculum, the role of teaching or assessing and learning or the objectives, they could be defined, but there is no necessity for you to decide it, or even if you have those in place, there is no guarantee that those will be met. So that is one thing. We'll see what objectives the students met, what they learned, but it is not guaranteed that you have the objectives doesn't actually means that you will meet them. And the assessment of the students is usually based on the non-referencing. So out of the performance of all of the students, they will be normalized, maybe in a curve, maybe a Gaussian curve or something like that. So whoever is in the top of the class gets the highest grade, or is supposed to learn more. And then whoever is in the following those, they will get the sequential grading. So now what I have done here is so this is completely my proposal here. So I was thinking after I read the forward design, okay, So I'm teaching University Physics 1 in my university here. So I was like, okay, what would a forward design lesson plan look like if I were to teach the University Physics 1 class in this model? So this is what I came up with. So the first thing is I have to decide a content. So let's suppose I want to teach the projectile motion. And then I decide the resource. So what resource do I want to use in my class? So I want my students to use the Physics for Scientists and Engineers. That's the book they will use. Now, how do I want to deliver the content in the class? So I would use the lecture with the PowerPoints, and I will write the equations on the whiteboard, and I will solve, and whatever is needs to be done, I'll soothe my students by doing that on the board. And eventually I'll have to assess to make sure that my students are learning. So I'll have one multiple choice questions on the projectile and one numerical question to calculate maybe the launch angle. So this is what I thought would give us an example or an idea of how the forward design lesson plan would be. And let me say it here. So when we are talking about these designs, as I understand now, is there are two things that we have to have in mind about the designs. The first thing is the design of the curriculum, which I already talked. It starts with the syllabus, and it includes the methodology, and it goes to the outcome. So it has all three parts. But what I'm talking about here is just the methodology part, just the lesson plan. So we can talk about this design in terms of the lesson plan, and we can also talk about the design in terms of the whole curriculum. So this is the lesson plan, how the forward design would look like. So that's my imagination, and we'll discuss on it. Now let's talk about the central design process. So the central design process puts emphasis on the methodology or the process itself. So what do you want to do in the class? That is the priority here. So for example, if I'm teaching the University Physics 1, then the content and outcomes are not chosen first. I would decide first what do I want to do in the class. For example, I may want to involve my students in the discussions. I may want to have my students solve the problem. I may want to have my students involved in some demonstrations and things like that. So once I decide what activities I want to do in the class, then I will choose what is the content I want to use for that activities. And that will also then define, okay, what will be the learning outcomes for the course. So that is what the central design, it doesn't put emphasis in the learning outcomes as well as in the content. It just puts the emphasis on the activities that we want to carry in the class. So this is also referred to as the progressivism because the learnings, the teachings, even the content, the outcomes, they will all evolve during the process. So during the methodology. So once you start doing those activities, that will decide what you want to teach. That will decide what objectives are achieved from the activities students are doing in the class. So syllabus and learning outcomes, they will be determined after students are doing those activities in the class. So there are no predetermined syllabus, then there are no specific goals or objectives to attain. So every students will do their activities and evolve as they are doing. So that means the contents may be different from students to students, as it really depends on how their learning evolves during the class activities. Now the teacher lesson plans as the ways of doing things, not as to cover some content or to meet the set objectives. So this basically is very engaging for students. So it's kind of, I think it has a lot of the techniques that active learning has it. So maybe students are involved rigorously in the discussions, interpretation, solving problems, self-reflection, and so on. So this curriculum design really takes the idea of teaching and learning as the limitless power and possibilities. So it resides on the idea that the curriculum should not be limited just by setting some mere objectives or setting some mere contents beforehand. So it advocates that we should as knowledge is speculative, we should give the immense power to the explorative learning, so that if we already decided what objectives to meet, or if we already decided what contents to cover, that may limit the possibilities of learning. So that's why the central design puts a lot of the effort on the process. Now, as we see that the central design, it really evolves when the activities are carried out. So we know that those activities will determine what contents to cover and what objectives to gate. And teaching and learnings and the assessment, they are informing to each other at every stage. So you'll do some, you'll have some content, do some activities, and then that will definitely have some outcomes, and you'll assess just to see either students have learned or not. But in all of these steps, you are just learning. So after you assess, then you see, okay, I could have done something different here, or students could have taken a little bit of different path in terms of the learning. So that assessment will now give feedback to the content, and then that content will yield a new outcome, and that new outcome will again be assessed. So that assessment will again teach you something, and that you will use as the feedback to the content. So this is just going in a circle. So this is just evolving just by taking feedback from teaching and learning to the assessment, and from assessment to the teaching and learning. So then I thought, okay, so what would be a central design process? What would be a central design lesson plan for the University Physics 1? So here is what I came up with. So I would first have to decide what activities I have to do in the class. So I would lecture for some time just to give an idea to the students what topic I'm covering. Then I want to involve them in the discussion, maybe some problem solving and demonstration again. Now, I will again select the projectile motion. And after that, obviously the learning outcome would be to understand the projectile motion. And so students will discuss with each other, they will use the resources, maybe they'll do some activities for the demonstration. And at the end, how do I assess if the students have learned or not, if the learning outcomes have met or not? And again, I have the learning outcomes here, but actually the learning outcomes could be different for each student, because this just evolves during the class. What the student is learning, what he thinks is the next process in the state of the learning. So even if the learning outcome is, I have this learning outcome here, this is a little bit broad and could be modified for different students. Now, the assessment could just be self-evaluation when the student is discussing with their peers, or when he or she is solving the problem or doing in-class demonstrations. He could self-decide how much he or she has learned. Or I can just have the students write the end of class summaries, and just to let me know what they learned or what they did not, or what they thought about the class. So maybe this is what a center design lesson plan looks for the University Physics 1. And this is my proposal, just reading the paper. So the paper was written in terms of the linguistic class. So there are a lot of the things that are not as clear, or the steps not as much related. Sometimes it felt to me like that, okay, we are teaching physics, this is linguistics, so there's sometimes I have hard time relating those things, but this is what I think would serve as the central design lesson plan for the University Physics 1. Now let's talk about the backward design process. And so the backward design process puts the emphasis on the outcomes. So the objectives, the learning objectives and the outcomes are determined first. And then we'll decide what content we need to attend those outcomes or the objectives, and what process we want to take in order to achieve those outcomes. So the whole thing of the syllabus, or the whole effort of the process, is to attain the objective. So the objective is the first priority here. So this approach is also referred to as the ends means approach, because we set the objective first, that the ends we want to get from the class. And then the means mean the methodology we want to use to achieve that ends. So this is also called as the ends means approach. So this approach starts with the clear understanding of the objectives in mind. What do I want to teach my students here? And then there is a considerable degree of the freedom that we can choose the methodology to get that objective. So there is not any set methodology. You must use this. I don't think there is anything like that, but what you can do is you can try a lot of the methodologies that you think may be applicable, and you can choose the best for you. So, but you have to have in mind that any methodology that you can that you decide to use must attain the objectives that are predetermined. So a criterion referenced approach would be used for the assessment. So instead of just going with the norm approach, it will be the criterion referenced approach, meaning out of 100%, how much the students is able to learn, able to score in the assessments. And as opposed to the central design, there is no individually determined learning outcomes here. So in the central design, it was explorative. Students can carve their own path. So they will have their one understanding strategies and understanding level at the end of the class. But there is nothing like that in this one, because the learning outcomes are already predetermined. Everybody has to be measured on that predetermined scale here. Okay, so how do we implement the backward design process? So the first thing is we have to have the objectives. So that means we need to diagnose the need. So meaning, for example, let's say I'm trying to set up my University Physics 1 class, the curriculum, the whole curriculum. Somebody already did that for me, but what this would have done if it was a backward design class is the first thing is so diagnosis of the needs, meaning who will be taking the University Physics 1 class. So for example, let's say if the engineering students will be taking this, then which physics concept and the topics they need to learn from this class. So that will, after we diagnose the needs, that will set our objectives, what they need to learn from the class. So let's say they need to learn one-dimensional motion, they need to learn projectile motion, two-dimensional motion, they need to learn vectors and something like that. So once we diagnose what the need of those students are, then we formulate the objectives and we decide the content, what content to use in the class. Now, we'll organize those content, meaning we'll have the simpler content first, and then we'll go to the complex. So if you want to cover one-dimensional and two-dimensional both, we should first cover the one-dimensional and then go to the two-dimensional. And we'll select the learning experiences, meaning what methodology we want to use. For example, we may want to lecture, we want to have them practice, we want to have them discuss, we want them to solve the problems and things like that. So we'll select whatever we want to use in the class, and then we will organize those. So when do I lecture? So what do I do? When do I give them the quiz questions? So what do I cover in the homeworks and things like that? So we'll organize those learning experiences, and then we'll decide how to do the assessment. So and this assessment is very important here because the learning objectives are already set, and we have to meet those learning objectives. Now, if we want to make it a little bit simpler, this is how the backward design will work. So there are really 3 steps, and the fourth step is to ask a question. So the first step, identify the desired results, meaning what do you want to learn from the class? So determine the acceptable evidence of the learning, meaning what is your criteria of assessment? For example, when do you think that the students have a reasonable learning from the class? Meaning, let's say we set 70 as a passing grade. So if out of 100 students are having 70 or more, I will accept that is a acceptable evidence for learning. And then I'll plan the learning experiences. So the first, objectives. The second one is the assessment, and the third one is the methodology. But now, one important question we have to ask ourselves is, are the desired results, assessment, and learning activities aligned? So if they are not aligned, then it merely will be a technical subject. So we have the objectives, and then we have the assessment. We also have the teaching methodology, but the important question is, if they are not aligned with each other, then there is a danger that there is a risk that the objectives will not be made. Even if we think the objectives is made, we may not. So that is the last question we have to ask, and that is the one that aligns everything into perspective, and that will decide if our class is back designed in a very good manner or not. Now, here is what I thought would be the backward design lesson plan for the University Physics 1. And so I searched for a lot of, I do not have a set forward backward design class. So what I did was Googling around, and then I found this lesson plan for cell biology by Dr. Corey at Michigan State University, which I liked the most among all the others that I went through. So what I did is she have a backward design lesson plan for the cell biology. So I went through that, and then I was like, okay, what do I do in my class if I want to have the backward design class for the University Physics 1? So then let's say again, following the projectile motion, the first thing is I have to set the objectives. So I would have the learning objectives to understand the projectile motion. Learning outcomes, and then I could have multiple learning objectives to attain that learning outcomes. Maybe, and it really depends on what aspect of the projectile motion I want to teach them, right? So maybe I have to have them identify the horizontal and the vertical motion. I want them to calculate the height and range of the projectile along with the variation in the launch angles. And I may want to have them calculate the velocity and the acceleration at the different at the different points in the path of the projectile. So those are my learning outcomes and the learning objectives. Then what do I do in the class to attend those activities, to attend those objectives? So I may have them read some sections of the textbook. I will lecture for some time in the class, and I will have them take some quizzes. And during the quizzes, I will have them discuss with each other. So I will have them present their reasoning to their peers, and then students will discuss with each other why their answer, what they think their answer is right or wrong. So I'll involve them in the discussion. I'll also give them some problems to solve. So I'll first walk them through the similar problem, and then I'll assign them some problems to solve. And lastly, I'll do some homework problem to calculate the horizontal and the vertical velocity of the projectile. And then if I want to do the assessment, if the students have learned what I want them to learn from the class or not, then let's say I will have one multiple choice question to assess the higher order understanding of the projectile motion. And I'll have the numerical question for them to calculate the launch angles. Now, here's the question again of the alignment. So do the learning activities, my methodology, and the assessment, do they align with each other or not? And are they aligned in such a way that it helps for us to attain these learning objectives or not? So that's what we have to think. And one of the way is, so let's say I'm saying here in my objectives that identify the horizontal and vertical motion. So if I did not put it anywhere, either in the lecture or in the solving problems or in the discussion about this horizontal and vertical motion, then these are not aligned. So I was like, I can just set these objectives, and I can go ahead and teach the projectile motion the way I want. So if I just did that, I just missed that alignment here. And now, let's say I taught something, but if my assessment questions are not aligned with my teaching and with the objectives, then we miss that alignment here too. So we can have that because we know what to teach or what we want to teach, but we really have to look at our objectives, and we have to have our methodology and assessment aligned to our objectives so that this method works pretty well. Okay, let's see. Let me go back. Okay. Now, here's the comparison of the three approaches. So we went through the all of the approaches, and there's a pretty good comparison of these three approaches in the paper. But that was for the linguistics. So some of the comparison were pretty, I think, applicable to the physics too, but some of the language was just for the linguistics. So I have a little bit hard time. And I tried, as per my understanding, as far as I can understand, I tried to express those in terms of the physics, but we can have a lot of the discussions here. And I do think we should have a lot of the discussions here. So syllabus, in terms of the syllabus, the forward design is content-centered. we'll decide the content first, central design activity-based, the forward design need-based. So we'll do the need analysis, and whatever is needed for that group, we'll put that as the content. It is predetermined for the forward design and the backward design, but the content evolved during the class for the central design. So forward and central design, it is sequenced from the simpler topics to the complex, but central design, no control on that, just evolves during the class. Again, forward and backward has the linear progression, but sequence may be different, and it may be defined by the learner itself for the central design. So the methodology, it's a teacher directed for the forward design. And there is a key role for the teacher, but a lot of the learning is done through the practice in the backward design. For the central design, it is learner-centered. So for the forward design and the backward design, there will be the practice and the control of the elements. There is more control by the teacher in the methodology for the forward design, but there will be some facilitating and practicing of the real-world problems in the backward design, where the students will engage themselves actively in the central design. In the forward and backward design, again, we'll deal with the explicit presentation of the rules and the physics equations. We also do that in the backward design, but we try to emphasize more on the accuracy, just not on the explanation of the equations, but also how to implement them and how accurate those are in terms of the implementation. And for the central design, accuracy is not much of that of the importance, but what do they learn and what is the meaning? That's what is prioritized. Now, so the role of the teacher mainly acts as the instructor, the transmitter of the knowledge, and reinforcer. So he's the key element and the central element for the forward design. In the backward design, teacher is there. He acts as the organizer of the learning experiences. So meaning what learning activities he wants to put in the methodology. And he's the model of the target performance skills too, because he should be really familiar with the theory and the practice and the knowledge of the subject matter as a whole. So he acts as the model for that, and he also plans for those learning experiences. So which one to do first, or how to sequence those. In the central design, he's just the facilitator. He doesn't dictate the whole class, but he acts as the role of the facilitator. He gives some topics, and then he interacts with the students and what help they need. So he's a negotiator of the content and the process. So depending upon the learning level of the students, what may be the next step, he's one of the negotiator, but we can also see that the students is the negotiator also. So there happens a negotiation between the students and the teacher on what to do, what to learn, and how to learn. So the teacher acts as the encourages of the learner. So he's a facilitator, negotiator, and the encourages of the learner. Now the role of the learner, it has almost the same role here too. He's the negotiator, and the student is the negotiator, and the student is the responsible for the learning and learning and whatever topics he wants to cover in the class. So the student himself is responsible for that. So how much he wants to negotiate with the teacher, how much he wants to learn, or how much he or she wants to learn, it really depends on the learning level and the interest and exploration the student has done in the class, and the student will be actively engaged in the class. Now, as a role of the learner for the forward design, we emphasize an accuracy and master of the content, whatever content is given. For example, the acceleration or the velocity, we want them to mastery on that. And application of the learned material to the new context. Definitely, we learn the theory and maybe we apply that to solve the problems. And we want our students to understand which physics rules or equations and where to use them. It's a similar role in the backward design in terms of the learning, I think. So application of the learned material to the new context, where they should understand the physics rules and the equations. But a lot of the emphasis on learning through the practice. So they will see how to do that, and they do that by themselves. So with practice and feedback from the teacher, they will go on learning. Now the assessment for the forward design, it's a non-referenced. For the backward design, it's the criterion referenced. In the central design, it's a negotiated assessment. Sometimes you can have the self-assessment. Sometimes you may have the formative assessment. It really Sometimes you just maybe the self-reflection. So you just develop the capacity for the self-reflection and self-evaluation. For the forward design, it usually is summative as it's for the backward design. So forward design, there will be the explicit assessment of the learning, but for the backward design, the assessment should be designed in such a way that it not only assesses the student learning, but it also focuses on the improvement of the student learning. And in both of these designs, we want the students to master the physics topics that we want them to learn from our class. Now, what do critics say about each approach? So forward design, people usually criticize that it's a plan without a purpose. So it's a very good plan. It has content, and there is the individual involved in setting this plan is knowledgeable in the subject. So it's a good plan, but it lacks the objectives. So that's what people say about it. Now, central design, it's usually criticized for hands-on without being minds-on. So you just decide the activities first. You don't have the set content and you don't have the set objectives. So for those students who do not have any background, they will do those activities, but maybe there's a chance or there's a risk that a student may not learn that much from the class, because the teacher here is only the facilitator. He's not the key role. He doesn't have the key role in the classroom. Now for the backward design, so as there is one major line here that people usually say for the danger of turning the teaching into the technical and mechanical exercise, because that is what I was talking about when I was talking about those alignments. So if you just have your objectives and then activities and then assessment plans, but if they do not align with each other, it will just be technical. So you have set objectives. It's like you want to go somewhere. So you want to go there somehow. So maybe what you'll do is you'll not have a lot of the explorative learnings. So you will, so by setting the objectives, you have already limited what you can learn from the class. So the worthwhile learning experiences may be missed, which is part of the central design. So that is what people usually say about these designs. Now the question comes to which method is best. So as I read the books and the other the paper and the other resources, so I do think that there is no method like the best method. It really depends on what circumstances you are in. So there are certain points to consider before choosing which method to use. So is it a small scale class or the larger scale class? So what are the instructional materials and the tests and what role you want to give to them? How much are the teachers trained, and what roles do you want to give to the teachers and learners? Meaning how much of the freedom you want to assign to them? What is the level of the expertise of the teacher in the physics, and how much you want the teachers to be involved? Do you want them to involve just in the methodology, or you just want them as the facilitator, or you want to involve in the design of the whole curriculum? Now, how much of the freedom, I already talked about the autonomy, the freedom you want, and how much of the professional development is available for the teacher. So these are the points to consider before we can decide which method may be the best method for the circumstances we are in. Now, what would be the certain points that you can have so that you may decide which way to go? So a forward design method may be useful if you already have the mandated curriculum in place, and you just have the textbook and the commercial materials as the resources if your class is pretty large. And tests and assignments are designed centrally instead of you designing those. And if the teachers do not have as much expertise as needed in the subject matter, so you can just limit to the content in that context. And there are not much professional development opportunities available for the teachers. Now for the central designs, the teachers, if you want to give considerable amount of the freedom to the teachers and the students, that may be the way to go for that course. The teachers should be very well trained, both in the activities the students are doing in the class, as well as in the underlying theory. And in such cases, like there should be some expert design teaching solutions available, because this is the explorative class. So every student may go in a different path. So this teacher should be smart enough for them the teacher is expected to interact with them and facilitate the discussions for each student, and each students may have the different path. So there should be some guidance from the expert. Okay, if you run into this problem, this is how you tackle that. So those kinds of things would be necessary for the central design. Now, for the backward design, a lot of the resources is available because you have because you have to do the need analysis. So there should be a lot of this study. For example, if you want to set a course for the health professionals, physics course for the health professionals, then you should have a team doing the research. Okay, what are the application topics? Which topics in physics are applied in their fields? And everybody has a different field within the health, so you should have a different analysis for that. So usually regarding to that resources, these curriculum development activities may be carried out by the university or the central or the state level, because it needs a lot of the resources for that. And it gives little freedom for the teachers to select the content, or there is no freedom to select the content. The content are already decided. The teacher's role is only to implement that content, and the teacher can try the different methodologies and decide what is the best methodology to attain those objectives. And in this process, a high degree of the accountability is expected, because you do the need analysis, invest all of the resources, set all of your objectives, and as it is objective based, you should have aligned everything, and you should be able to define the accountability at each stage. So that's when the backward design may be useful. Now, when I was doing all of these, so one of the question that came to my mind was, so there are two different things in terms of the design, as I understand. So one is the whole curriculum design. Either the whole curriculum is starting from the syllabus to the objective and assessment is forward, central, or backward designed. And the thing is, when you implement that forward, central, or backward design lesson curriculum, so do you have the backward design or the forward design or the central design lesson plan? So actually in the backward design, everything should align, right? So I have this question in my mind. So do you have a backward design lesson plan for a backward design curriculum? Because the curriculum may be backward designed, but your lesson plan may not, right? So what I wanted to do is I wanted to go and look at my one lesson plan in University Physics 1. So this is already what I presented. And it happens that all of that I have put together here, just modifying what Dr. Corey has. So this is everything that I'm currently doing in class. So I put here only the things that I'm currently doing. So what I usually do is I give them the mini lectures. I ask them the quiz questions, I involve them in the discussions, and I solicit the answers for twice, and just to see if the discussions has helped or not. And then I show some examples on how they can solve the problems, and afterwards I give them this problems to solve, and I assign the homework problems and the quizzes to them. So this is all of the activities I'm doing in my class. So this is how we already talked about it, but this is how my class looks like. But this is the objectives I have in mind. I do not tell explicitly to the class, and I don't think if that is necessary to tell them in every class. And I'm all pretty aware of this alignment. Now, what I wanted to do is go ahead and see. So we talked about the differences in these three methods in terms of the syllabus, methodology, role of teacher, role of learner, and the assessment. So what I wanted to do is I wanted to do all of these topics within my course and see which model they fit. So what I did is I went to and look at the official syllabus. I have my one syllabus, but I wanted to go and look at the university website. I downloaded the official syllabus and then I looked at it. So it is for the University Physics 1. So it explicitly says that this physics is designed for engineering and physics majors, which I interpret as the need-based. So they have done the researches what the engineering and the physics majors need as the topic in this class. So need-based analysis was done. So the objective was decided, and there was a predetermined content to attain that objective. And the syllabus topics are sequenced from simplex to complex, simple to complex, meaning maybe one-dimensional motion first, then the two-dimensional motion, and then maybe circular motion. And it's a linear progression. So that fits the backward design. So I do believe that the syllabus was backward designed. Now, this is my methodology. I use mini lectures in class problem solving discussions where they have the opportunity for self-evaluation, critical thinking, reasoning ability, problem solving, etc. I do still think it's a backward design. It has the components of the active learning, which also is the focus for the central design, but I do think there is no criteria or restriction on which methodology you can use in the backward design. So it has the component of the active learning, which are the components of the central design. But all in all, you can choose any methodology you want. So I do think it fits the backward design too. Now, the role of the teacher. So as a role of the teacher, I do behave as the instructor because I do dictate the content I want to cover in the class. So I act as the transmitter and reinforcer of the knowledge. I do facilitate the discussions and in class problem solving where I do not give them the active directions on what to do, but I give them the question and then I let them discuss with each other. If they want to ask me any question, they can ask me. I'll just facilitate the discussion. I may say, okay, this is the direction for you to think. So I do think I act as the facilitator there, and I do act as the organizer of the planner of the learning experiences because I have all of these activities that I want to do in the class, and I plan those thinking based on my knowledge of what I'm doing the best in the class. So I do think at the role of the teacher, I think I have all three designs. So this first is a forward design, the facilitator, the central design, and the organizer and the planning of the learning experiences is the backward design. So I think I have a combination of all three in my class as the role of the teacher. Now for the role of the learner, I do expect my students to have the accurate mastery of the content, and I want them to apply in the new context. I want them to learn the understanding of the physics rules and equations. So that is all what fits in the forward design. And I do have active engagement person for them where they are discussing and doing the self-evaluation and the reflection and have the critical thinking. That's what the active engagement is. So that fits the central design, and I have a lot of the practice opportunity for them. So I think that fits the backward design. So I think I have all three components in terms of the role of the learner. And for the assessment, I use the criterion reference, which is backward design. I use both summative and formative because the summative are the tests and the formative are the discussions. I do assign them 5 or 10% of their class activities. So how much they involve in the class, how much they involve themselves in the class, how much they take part in the discussions, how much they solve in the class. So I have some a person 5% or 10% of my grade that goes in the class activities, so which is formative one. And I have, so while they are doing the discussions and the in-class practice questions, they have the opportunity for the self-assessment and the improvement. So I think that's for the central design. And a lot of my maybe 70 to 80% will come from how they solve the topics in the homework and how they solve the problems in the test. So I think that's the backward design, what I use the criterion reference. So I do think in terms of the assessment, I do have the components of all three designs. So going backward, my syllabus, I think, is completely forward design. So the curriculum is forward design, backward design, my methodology is backward design. But for the role of the teacher, role of the learner, and assessment, I do think I do have the component of all three designs if I understand these designs completely. All right, those are my references. And with that, I will have some questions here. Thank you.
Yeah, thank you, Dr. Nawaraj Dahal sir, for your excellent presentation. It is actually, while I was listening to your presentation, what came in my mind is the power of question, power of asking question. Actually, this session, this presentation was built on the question asked by Dr. Chandramani Adhikari sir, who asked what is the difference between forward and backward design. And so I found this paper, which is used in linguistics, in language teaching, but very beautifully, Dr. Dahal connected that with physics, like that is what is actually innovative applications of the literature in our classrooms. So thank you so much. If any questions or any comments, so this is the time. Probably we'll do for 5 minutes, and then I will stop the recording and we'll do informal discussion. Thank you so much. So you can type the question in the chat box. I can read that, or please feel free to unmute and ask the question directly to the speaker. Or if you would like to contribute, I mean, your reading of the paper, which was presented by Dr. Dahal, you can also add your views on the paper. Okay, it looks like that you did such a good job that there are no questions. So what I do, oh yeah, here is a, it was, oh yeah, thank you so much for the comment. So what I do is, let me stop recording now. And by the way, this will also be shared in the group. Probably this is very good presentation. I might get permission from the presenter and then publish in maybe YouTube. So with that, so let me stop recording and then go to informal sessions. So stop recording.